Evening, students. Good evening, everyone. Friends, able to hear? Vaishnavi, Aravind, Admita, Nitish.
Yes, sir.
Solved any numericals in limits? We done up to question number 23. Am I right? See the screen? We done up to question number 23. We have to start from 24. So 24 onwards, all the functions are piecewise functions. If you draw the graph for these functions, you won't get a continuous graph. Might be different, might be straight line and curve. Straight line split it into different positions. That kind of graphs will come. So at these functions, we have to be a little bit careful. So these are called boundary values, where the function will change at these values. He's asking, mostly the questions will ask, find the limit at that boundary values or a differentiation of the functions at that boundary values. Limit extends to 1 f of x, where f of x is having two functions. First piece was x square minus 1 for x less than or equal to 1, minus x square minus 1 for x greater than 1. That means if x is 1 plus, anything 1 plus, your f of x should be minus x square minus 1. That is the meaning of this statement. If x is equal to 1 or 1 minus, that is less than or equal to 1, x square minus 1 is the f of x. So to understand this existence of the limit, purely we can able to calculate when x is approaching 1, left side and right side, how the function is behaving. So calculate the left hand limit. Limit extends to 1 minus f of x will be equal to limit extends to 1 minus. If it is 1 minus, the meaning of 1 minus is x is approaching almost equal to 1 but less than 1. If x is less than 1, what function I have to take? X square minus 1. If I am substituting this limit in this 1 square minus 1, 1 minus 1 is equal to 0. If I am going for right hand limit, limit extends to 1 plus f of x. The meaning of 1 plus is greater than 1. So limit extends to 1 plus minus x square minus 1 is the function. If I am substituting 1 here, the answer is minus 2. The answer is minus 2. So what is the conclusion answer we can write here? We can write limit extends to 1 minus f of x is not equal to limit extends to 1 plus f of x. That is, left hand limit is not equal to right hand limit at x is equal to 1. So the limit of the function limit extends to 1 f of x does not exist. So this is how we can discuss the existence of the limit at a particular given point. Same question, if I'm taking some other values, it might exist. We can't say. That is depends upon the at what value they are asking us to calculate the limit. That will decide. So observation of the question and its boundary values is very much important to solve the questions here. Is it clear? Shall I move to the next question? Students? I can move to the next question. Guys, will able to hear?
Yes, sir.
Yeah. Please try by your own. Yeah, sorry. Whenever this is called identity function, if mod x by x, x by mod x, these functions are called identity functions, the name of the functions. So this is also piecewise function. So 25th, the given is limit, find the limit x tends to 0 f of x. And f of x is like this. F of x is mod x by x for x not equal to 0, 0 for x is equal to 0. So how to do this question? First of all, you have to analyze this function. X not equal to 0 means what? In a number line, minus infinity to 0, and from 0 to infinity. If x belongs to this region, then f of x will be equal to mod x by x. And I have the analysis here. Mod x means whether x is positive or negative. Mod x is always positive. Suppose if x less than 0, that is x is negative, your mod x will become x and x will become minus x because it is negative. So my f of x will be equal to x by minus x. If I am cancelled, it is minus 1. So this is important, rewriting the function into exact formats. If I'm this is valid everywhere. It's not only here. Whenever you are getting mod x by x, and based on these boundary values, you have to decide. If x is greater than 0, that is x is positive. Whether x is positive or negative, mod x is always plus x and x is always plus x. In this case, my f of x will be equal to mod x by x, that is plus x by plus x, it will be plus 1. So how I can rewrite this function to understand very clearly? So my f of x is, if x less than 0, minus 1 for x less than 0, 0 for x is equal to 0, plus 1 for x greater than 0. See, this is a interval minus infinity to infinity. I defined my f of x. Now you proceed to the quotient, then it will be easy. So wherever you are getting f of x is equal to mod x by x and limit x tends to 0, and they mentioned they will say like this. Yeah, mod x by x is for x not equal to 0, 0 when x is equal to 0. When x is equal to 0, they mentioned 0. So this is a conversion of that function into in a standard format. It's all are constant functions. Now how to apply limit x tends to 0 minus, this is left hand limit, f of x. X tends to 0 minus means it's less than 0. If it is less than 0, limit x tends to 0 minus minus 1. It's a constant function, so it is always minus 1. It's a constant. Same as if I'm taking the right hand limit, limit x tends to 0, f of x will be equal to limit x tends to 0 plus 1. So the answer is plus 1. So straight away what I can write here, the left hand limit is not equal to right hand limit. So limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x. So at limit x tends to 0, f of x does not exist. Hope we are clear what I am saying. Is it clear? Shall I move to the next one?
Yes, sir.
Next one is also same. Next one is also same. Instead of x mod x by x, here x by mod x. So anyone can give answer. Same way, 26th one. For x less than 0, x by mod x will be equal to minus x by x, because modulus will use anything is plus x, so minus 1. For x greater than 0, that is x is positive, x by x mod x will be equal to plus x by plus x, it will be plus 1. Now if I am taking limit f of x limit x tends to 0 minus f of x. 0 minus means less than 0. If it is less than 0, x tends to 0 minus minus 1. So answer is minus 1. Limit x tends to 0 plus f of x will be equal to limit x tends to 0 plus. If it is greater than 0, the function value is plus 1. So the answer is plus 1. So I can write limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x.
Here also limit does not exist.
Yes, here also limit does not exist. Limit does not exist when x is almost 0. Limit does not exist when x is almost 0. So carefully you have to understand, because if I'm taking limit x tends to 0, f of x is 0. Even three things are different here. If x is equal to 0, straight away you can say f of x is also 0. It is given in the question. It is having three different functions. It is varying throughout the real numbers, three different formats. One is plus 1, one is minus 1, one is 0. Next one. How to do 27th based on the previous discussion, how we can approach 27th one. Students, simple. The given question is find the limit x tends to 5 f of x, where f of x is modulus of x minus 5. Modulus of x minus 5. It's very simple. I'm taking left hand limit. Limit x tends to 5 minus f of x. So limit x tends to 5 minus modulus of x minus 5. You can take a limit separately. According to algebra functions, I can say limit x tends to 5 minus mod x minus limit x tends to 5 minus 5. So this will be 5 minus constant, limit is a constant, so answer is 0. Same as if I am talking about right hand limit, limit x tends to 5 plus mod x minus 5, this also 5 minus 5, 0. My left hand limit will be equal to right hand limit. So I can say limit x tends to 5 f of x is equal to 0. The value of the limit at x tends to 5 is 0. Is it clear? How I wrote the conclusion answer here? Anyone having any doubts, please, before going to the next question? Students, shall I move to the next one?
Yes, sir.
We done this one. Nice question. This is exam point of view question for class 2. There are three regions. The value of x is less than 1. That means from minus infinity to 1. F of x should be a plus bx. And at x is equal to 1, f of x is 4. And x greater than 1, that is 1 to infinity open braces, f of x is b minus ax. That is the meaning of this function. He is asking the limit is existing at x tends to 1 and that value is f of 1. Limit extends to 1, f of x is equal to f of 1. If x is equal to 1, my function is 4, that is equal to 4. This is possible. Limit extends to 1 minus f of x must be equal to limit extends to 1 plus f of x, which is equal to 4. Then only it is possible. Then only it is possible. So how to do this question? First calculate the left hand limit by using as usual. So limit extends to 1 minus, if it is less than 1, my function is a plus bx. So if I'm substituting these values a plus b into 1, so the left hand limit is a plus b, which should be equal to 4. It should be equal to 4. Same as if I'm taking right hand limit extends to 1 plus, if it is greater than 1, my function is b minus ax. So b minus a, which is should be equal to 4. Then only this is exist, because he clearly mentioned f of 1. F of 1 is 4. So limit extends to 1 minus f of x must be equal to limit extends to 1 plus f of x. From here I can conclude a plus b is equal to b minus a is equal to 4. A plus b is equal to b minus a is equal to 4. How you can solve this one, students? I'm having a plus b is equal to 4 minus a plus b also 4. I'm adding what I will get solving these two equations. 2b is equal to 8, b is equal to 4. If I'm substituting here, a plus 4 is equal to 4. From here, a is equal to 0. So it is the values of a is equal to 0, b is equal to 4 is the correct
Sir?
values. This is the limit. Yes, please.
Sir, can you repeat the first step again, sir?
Which one?
The first step.
Here?
Yes, sir.
Yeah, that is given data. Huh? What is the given data? If limit of the function is exist and it is equal to f of 1, then what is the possible values of a and b? When it is possible? When the limit of a function is possible, left hand limit must be equal to right hand limit, which is equal to f of that value. So I have to take left hand limit is equal to 4, right hand limit is equal to 4, because if I'm substituting x is equal to 1, the answer is 4 from the given data only, that also. He given this value is equal to f of 1. F of 1 is nothing but 4 only, no? Which is equal to your left hand limit is equal to right hand limit. So
Yeah,
my
okay,
left
sir.
hand is a plus bx. At x is equal to 1, a plus bx is a plus b, which is equal to 4. Right hand limit is b minus ax. That is b minus a is equal to 4. So when it is possible, if a is equal to 0, b is equal to 4, this is possible. Rest of other values, suppose if I am taking other than 0, 4 for a and b, the limit does not exist. Understood? What is the
Yes, sir.
meaning of? Yeah. Next one. Let a1, a2 and an be fixed real numbers and define a function. So how the function is f of x will be equal to x minus a1 into x minus a2 and so on x minus an. So limit x tends to a1 f of x for some values a is not equal to a1, a2, a2 and an, then compute the limit extends to a where it is not equal to any of one roots. A1, A2, A3, A4 or an are roots of this equation. So I am taking a value which is not equal to any one of its root, then what is the limit? There are two questions here. If x is approaching its any one of its root, then what is the limit? If x is approaching some other value which is not equal to any one of its root, what is the value? How will you deal this question, students? It's very simple. I'm applying the algebra functions. I'm applying algebra functions here. First, I am taking this one. Limit x tends to a1 f of x. That is limit x tends to a1 x minus a1 into limit x tends to a1 x minus a2 and so on. Limit x tends to a1 x minus an. If I am applying the limit, straight away I will get a1 minus a1 into a1 minus a2 into and so on, a1 minus an. So because of x is approaching the one of its root, at one position you will get the 0, a1 minus a2 and so on, a1 minus an. So answer is 0. Is it clear? That is f of a1 is 0. The limit when it is approaching any one of its roots, it is 0. And if it is not approaching any one of its roots, what is the answer? From here, anybody can tell. Limit x tends to a f of x, since a is not equal to a1, a2, a3 and so on, an. So limit x tends to a x minus a1, x minus a2 and so on, x minus an, which will give the answer a minus a1, a minus a2, a minus a3 and so on, a minus an, since a does not belongs to a1 comma a2 comma and so on, an. Anything, whatever the format you want, you can represent in this format. Where a is never equal to any one of its roots. That is a given data. So two cases we are solving here. Clear? Students, are you clear what I'm saying?
Yes, sir.
Move to the next question. Yeah. How we will deal this question? Find the values of a. Does limit exists? If limit exists, find the values of a. So if I want to say the limit is exist at this point, limit x tends to a minus f of x must be equal to limit x tends to a plus f of x. Then only I can say limit exists, which is equal to f of a. So he's asking for what values of a does limit exists. I'm taking a minus. Limit x tends to a minus. If I'm substituting in f of x, I don't know which value I have to take. Here I have to split as the cases. Case 1. If a is less than 0, what is my f of x? If a is less than 0, this is my f of x. So limit x tends to a minus modulus of x plus 1, which will be modulus of a plus 1. Case 2. If a is greater than 0, if a is greater than 0, what I will get? Limit extends to a plus, f of x will be equal to limit extends to a plus mod x minus 1, which is equal to a minus 1, which is equal to mod a minus 1. If third case, if a is equal to 0, limit extends to a plus f of x will be equal to limit extends to a minus f of x. When a is equal to 0, straight away you can write, sorry, both the things are not equal here. When a is equal to 0, what is the answer? Function is what? A plus. A plus means little bit greater than 0. So mod x minus 1. Mod x minus 1. So this is 0 minus 1. The answer is minus 1. Same as if a is equal to 0 and limit extends to a minus f of x, which will give the 0 plus 1. It is plus 1. So we can conclude here 3 statements. The limit exists for all the values of a except a is equal to 0. That means a should not equal to 0, then the limit exists. Or you can say the limit does not exist at a is equal to 0. Simple. That means rest of all the values the limit exists. Hope you are clear. Shall I move to the next one? Students, please. Okay, go to the next one or not?
Yes, sir.
Last 2 questions they gave. Yeah. If the function f of x satisfies limit extends to 1, f of x minus 2 by x square minus 1 is equal to pi, then evaluate limit extends to 1 f of x. Here we can use algebra functions. It will be easy if I am using algebra functions. What is the meaning of algebra functions? What is the meaning of algebra functions? You can apply the limit separately and you can find out. But if I am doing that job, what will happen? See here. He is saying the limit of this function is exist. If I am applying the limit straight away, what I will get? Limit extends to 1. F of 1 minus 2 by 1 minus 1, which will give f of 1 minus 2 by 0, which is infinity. That is not equal to pi if I am applying. So what I have to conclude here, if I am straight away applying, it's not coming. So after some deductions, it is coming as pi. That means it should give some indeterminate format. If I am saying limit extends to 1, x square minus 1 is 0. For limit f of x, sorry, limit x tends to 1, f of x minus 2 by x square minus 1 to exist. When it can exist, the numerator also should be 0. X tends to 1, f of x minus 2 should be 0. From here, how to calculate my value? If it is not equal to 0, your answer is infinity. That means it is violating the given data. If I am considering, since f of x minus 2 is not equal to 0, then you will get some constant divided by 0, which is the value of the limit is infinity. So which shows the not equal to pi. So it should be some indeterminate form. If it is in this, then only I can say the limit can exist. From here, what I can do? How to calculate this one? Limit x tends to 1, f of x minus limit x tends to 1, 2 is equal to 0. Constant limit is its constant only. So limit x tends to 1, f of x will be equal to limit x tends to 1, 2. The answer is 2. So limit x tends to 1, f of x will be equal to 2. This is how we can discuss this question. Carefully, these questions are little logical based. F of x might be some expression, but at x is equal to 1, that expression value is 2. It might be x square plus 1, it might be x cube plus 1, it might be x power 4 plus 1 or minus 1 or what other thing. The whole value, if I'm substituting x is equal to 1, it is 2. It might be 2x plus 1, 2x plus, it's already, what is there? It's already f of x minus 2. So it might be x square minus 2, 1 minus 2, it won't come. So some expression. But that resultant is equal to pi. After deductions, and I will get the limit of that function is, the whole function is pi. So it is possible, because of the denominator is 0, the numerator also should be 0 to exist the limit. Then only some cancellations will happen. Then we will go to, we will apply the limit after some deductions. So this is how certain questions we have to discuss like this. The last question from the exercise. F of x is given for negative values of x, mx square plus n, for positive values of x, two functions again, between 0 to 1 nx plus 1 with closed braces, closed interval, and for greater than 1, it is nx cube plus n. So for what integers of m and n does both limits are exist? He's saying both the limits should exist. So I'm taking the first one. When a limit can exist, its left hand limit and right hand limit must be same. So I'm calculating for first question, limit x tends to 0 minus f of x. 0 minus is less than 0, it is equal to mx square plus n is equal to mx square plus 1. Limit x tends to 0, whose my answer is n. If I'm taking limit x tends to 0 plus f of x, which is greater than 0. So limit x tends to 0 plus, which is greater than 0. If it is greater than 0, just approaching little bit greater than 0, which will give 0 to 1 function. So nx plus m, which is equal to m, which is equal to m. So limit x tends to 0 f of x, for limit x tends to 0 f of x to exist, we must have LHL must be equal to RHL. So n is equal to m. So the condition to exist the limit of x tends to 0 f of x is n should be equal to m. Now, if I'm taking the second case, limit x tends to 0 minus f of x. So not 0 minus, 1 minus. 1 minus means it is not less than 0. It is just approximately 1 but less than 1. Approximately 1 but less than 1. Which function I have to take? Limit extends to 1 minus left hand of the 1 is equal to nx plus m. So if I am substituting here n plus m, limit extends to 1 plus f of x almost equal to 1 but greater than 1. It is nx cube plus m. Limit extends to 1 plus, which will give n plus m. Which will give n plus m. So what is your conclusions? When you can say limit can exist here? Here straight away I am getting limit extends to 1 minus f of x is equal to limit extends to 1 plus f of x is equal to m plus n. That is, I can say limit extends to 1 f of x exists for all values of m and n. For all values of m and n. Here no restriction. You can take any value for m, any value for n. But when it comes to first case, it exists only if n is equal to n. If I'm taking m, n should not be different. If I'm taking n is equal to 2, m also should be 2 for existence of the limit extends to 0. But in case of extends to 1, any combination of m and n values will be possible because the limit exists, left hand limit, right hand limit is m plus n. So you can choose any values m and n and it can exist. But x is equal to 0, m and must be equal. Understand what is the difference between both the questions? Anyone having any doubt so far? Students?
Understood, sir.
Yeah. So after all these deductions, we can make some standard limits, which will be useful to solve the certain questions easily. Some standard results. Some standard results in limits. Limit extends to a alpha is alpha, where alpha is a fixed real number. The second one, limit extends to a, x power n is always equal to a power n for all n belongs to natural number. Third one, limit extends to a, f of x is equal to f of a, straight away you can take, where f of x is a polynomial function. F of x is a real polynomial function. The fourth one, limit extends to a, modulus of x is modulus of a for all values of real numbers. And fifth one, limit extends to a, log x will be equal to log a for a greater than 0. For negative values of the logarithm does not exist for the negative values. Logarithms does not exist for the negative values. Now we'll see piecewise function limit standard results. So what are the piecewise functions we are having? First, when it comes to mind, if I'm talking about the piecewise function, greatest integer function and ceiling function. I can write the heading for this. Limits of the greatest integer function and ceiling function. Let a be the any real number in such a way. First case, if a is any real number but not integer. Hope you understand what is the meaning of any real number but not integer. That means a is not an integer. A is not an integer. So first result, limit extends to a, greatest integer function of x is equal to a. And for ceiling function, limit extends to a, the symbol for the ceiling function is like this, which is equal to a. If x is an integer, suppose if the limit x is an a is an integer, first one, limit extends to a, greatest integer function is a minus 1 for a minus, limit extends to a plus the greatest integer is equal to a. So the limit does not exist. The limit does not exist for greatest integer function if x is approaching an integer, because its left hand limit is not equal to right hand limit. Anyone having any confusion in this? Students, please. Students, please respond.
What else?
You understand what is the meaning of integer? Sorry, greatest integer functions. If you understand, that will be easy. Same thing will be applicable for ceiling function also. Ceiling function also at integral value. Suppose if I'm taking a is an integer, the limit does not exist. And later we saw some other deductions we already discussed. Limit extends to a, x power n minus a power n by x minus a is equals n into a power n minus 1. Based on this, we done some numericals. We'll go for some other results. Just hold on a second. Limit extends to infinity Find the value of sin x by x. Please calculate. If so far we are dealing with real numbers, we never done the questions related to infinity. What's your answer? Anyone can give the answer for this? How to approach if it is coming infinity? After this, we discussed limit x tends to 0, sin x by x is equal to 1, which is equal to limit x tends to 0, tan x by x. And in case of cos, it is 0, 1 minus cos x by x is equal to 0. This is one result. Limit x tends to 0, 1 minus cos x by x is equal to 0. This is also one more result. You have to keep it in mind. Based on this also, we covered some numericals. Infinity numericals only. If the x tends to infinity, those numericals we are not yet done. Few numericals we will do based on infinity. Yeah. So before going to the infinity numericals, certain things are not available in textbook. Might be, chances are very less asking these kind of questions. Limits of exponential and logarithmic functions. First, try to understand the properties of the exponential functions. Properties of exponential functions. If f of x is equal to a power x, then it is called exponential function. A might be e also, e power x or anything, where a is greater than 0 and a belongs to real number. Or I can say a is greater than 0 and x belongs to real numbers. First is a power 0 is 1. The second property we have to keep it in mind. A power x into a power y can be written as a power x plus y. Hope you can able to remember these things. For all values of x comma y belongs to R. Third one, a power x whole power y is equal to a power xy for all values of x belongs to R. And fourth one, a power minus x is equal to 1 by a power x. When it comes to denominator, automatically power will change its sign. Power will change its sign. So come to the logarithmic functions. So logarithmic functions means log of something. So how to deal these kind of functions comes in the questions. So I'm giving this right formulas. Limit x tends to 0, e power x is equal to 1. Limit x tends to some constant, e power x will be equal to e power c, since c belongs to R. Third one, limit x tends to 0, a power x will be equal to 1, a greater than 0, since the fourth one is limit x tends to a, log x will be equal to log a. A must be positive because the logarithmic functions does not valid for negative values. These are the straight functions. Limit x tends to 0, e power x minus 1 by x. This is equal to 1. If I'm applying directly 0 minus 1 minus 1 by 0, that is 0 by 0 indeterminate form. So after some deductions, you will get it is equal to 1. Same as limit x tends to 0, a power x minus 1 by x will be equal to logarithm of a, log a. Next one. Limit x tends to 0, log of 1 plus x divided by x is equal to 1. And the last one, limit x tends to 0, 1 plus x whole power 1 by x is equal to e. There is some constant, exponential constant. Are you clear, students, so far? Shall I go a few questions and come back to the question what I am asking with respect to infinity? How to deal the questions with respect to infinity?
Sir, is that 0?
Which one?
Limit sin
Correct.
x by x to infinity.
0. Limit sin x tends to infinity sin x by x. First of all, sin infinity. Sin is maximum. The input of sin is anything, but you will get maximum either -1 or +1. Even if you substitute infinity also, the range of sin function is plus or -1 only. In between -1 to +1. So how to make it? So only the logic is try to make the limit is 0 by substituting values. If x tends to 0, infinity 1 by x tends to 0. That is, if I am taking y is equal to 1 by x, my y tends to 0. If I am taking y is equal to 1 by x. From here, x is equal to 1 by y. This I can written as limit y tends to 0 sin 1 by y divided by 1 by y. Sin 1 by y divided by 1 by y. This will become how much? Limit y tends to 0, y into sin 1 by y. What is the answer if I am substituting? What is your answer? Guys, what's the answer? 0.
Sir.
Yeah. Can you evaluate this function? Limit x tends to infinity x square plus 1 under the root minus x. What is the value? If I am substituting the limit directly, I will get infinity minus infinity, which is indeterminate form. So how to solve this question? Students, please try explore it. How to solve this question? Whenever you are getting x tends to infinity, try to change the x values in the form of 1 by x's. How I can change? There only one option. Whenever I am getting this kind of irrational functions, only the rationalizing the numerator and only the option. If I am considering this is a fractional function, limit x tends to infinity root of x square plus 1 minus x divided by 1. I am multiplying root of x square plus 1 plus x divided by root of x square plus 1 plus x. This will become limit x tends to infinity. So it is looking like a square minus b square. So x square plus 1 minus x square divided by root of x square plus 1 plus x. So this will be limit x tends to infinity. X square cancel 1 by x square plus 1 plus x. X square plus 1 plus x. If I am taking x square common here, if I am taking x square common here, limit x tends to infinity 1 by, if I am taking x square common, 1 plus 1 by x square plus x. This will be limit extends to infinity, and this will be 1 by x root of 1 plus 1 by x square plus x. Again, I'm taking x common in the denominator. This will give limit extends to infinity 1 by x into 1 by root of 1 plus 1 by x square plus 1. Now it is ready to apply the limits. If I am applying the limit 1 by infinity into 1 by 1 plus 1 by infinity under the root plus 1. This will give 0 into 1 by 2, which is answer is 0. These kind of functions, say convergent functions, approaching 0 if it is x value is increasing, the f of x value is approaching 0. Is it clear, students, what I'm asking? Understood how I done this question?
Yes, sir.
The same method you can use anywhere when it comes to algebraic functions if x tends to infinity. Direct substitution is not working. You can use this method. Now, do this one. Limit x tends to infinity. Find the value of the limit where limit extends to infinity, where f of x is x square plus x plus 1 under the root minus x. Calculate, everyone. I will wait here. I need the value of this limit. Please, everyone, try this question. Same method. Multiply and divide with its conjugate rational function.
Sir, is it 1 by 2?
Yes, 1 by 2 is the right answer. If I am substituting limit directly, I will get answer is infinity minus infinity, which is indeterminate form. I'm taking the function x square plus x plus 1 under the root minus x into x square plus x plus 1 plus x divided by x square plus x plus 1 plus 1 plus x. Limit x tends to infinity. So from here, the numerator will be reduced as x square plus x plus 1 minus x square divided by x square plus x plus 1 plus x. So x square cancel. So what is remaining here? Limit x tends to infinity. If I am taking x common here, I will get 1 plus 1 by x in the numerator. In the denominator, if I am taking x square common, I will get 1 plus 1 by x plus 1 by x square plus x. And under the root, it is x square. If it is coming out, it will be x. I am taking x common again. X into 1 plus 1 by x. The denominator is x into root of 1 plus 1 by x plus 1 by x square plus 1. So if x is cancelled, now apply the limit. Now apply the limit. If I am applying the limit, 1 plus 0 divided by root of 1 plus 0 plus 0 plus 1. So the answer is 1 by 2. One more last question. Limit extends to minus infinity. X square plus 1 under the root by x. Find the value with the help of with the previous two question strategies you have to apply.
Sir, is it 1?
The answer is -1. Anyone got the answer? Students? Raghav, Shriya, Vaishnavi, Amsini,
Sir, how -1? Sir? Should be plus only.
Vesh. Students, anyone got the answer? Guys, respond. Yes or no or something. Amsini, Raghav, Harshida.
Sir, how -1?
Sorry, guys. Yeah, please now respond.
Sir, I am getting +1.
Yeah. See here, the common mistake will done by the students. I will explain here. See here, x tends to minus infinity. That means the x values are always negative. So when I am solving, whenever you are getting x square by x here, you should not straight away cancel as +1 here. If this is +1 only if x is positive. If x is negative, this will be -1. That we already done mod x by x concept. So that concept you have to keep it in mind here. X tends to minus infinity. If I'm taking x square common here, I will get 1 plus 1 by x square under the root divided by x. X tends to infinity minus infinity. If it is plus means right away this you can take as plus x. So that's the reason I'm taking this is mod x by x into limit x tends to minus infinity 1 plus 1 by x square under the root. Limit x tends to minus infinity mod x by x into 1. When substituting value here, it is 1. But limit x tends to minus infinity mod x by x is equal to minus 1, since mod x by x is equal to minus 1 for x less than 0. From here, we can conclude the answer of this is minus 1. Understand the logic?
Yes, sir.
Got it? So careful when the x is negative values. You should not cancel simply root of x square. Even in previous case, if I am considering plus or minus x square is always positive because it's a positive values. That's the reason you will get always positive numerator and denominator. But here, because x is negative always, the denominator is always negative, numerator is positive x. Whether it is negative or positive, the numerator is positive, but the denominator is negative here. So you will get negative always. That's the reason the answer is minus 1. So don't confuse students. So carefully, in some particular cases like this, you have to keep it in mind when you are cancelling x square by x values. Is it clear?
Yes, sir.
Yeah. One last question. One more last question. Evaluate the limit n tends to infinity sigma n cube by n power 4. Calculate and let me know what is the answer. What is the sigma summation of n cube values? Summation of n cube is how much?
N into n plus 1 by 2 whole square.
N into n plus 1 by 2 whole square. Correct? N square into n plus 1 whole square by 4. Substitute here first. If I am applying the limit straight away, you will get infinity by infinity. N tends to infinity, n square into n plus 1 whole square by 4 n power 4. So what are things can cancel here? 1 square cancel. Limit n tends to infinity 1 by 4 into n plus 1 by n whole square. This will be 1 by 4 into limit n tends to infinity 1 plus 1 by n whole square. So 1 by 4 into 1 plus 0. The answer is 1 by 4. Simple question. Is it clear, students?
Yes, sir.
Will I wind up the session? Please practice. If you are having any doubts, please let me know. The next class, we are going to discuss statistics, the last part of this first term portions. We'll meet in the next class. Bye, everyone.
Thank you,
Thank you,
sir.
sir.